how to build a shed from scratch in Autostrek. If you'd rather build your structure from scratch, instead of using the automated build features, here's a simple workflow. You only need two tools for this build: the tape measure tool in CC mode and the plane tool. Once set the first line and build the floor frame. Start by creating a line with the CC tape measure. Turn on Snap to Grid. Click once to set a starting point, then drag to define the direction. You can also type an exact length in the input box and press Enter. You'll see labels and a series of small planes along the line. If the labels get in the way, turn them off for a cleaner view. Each plane has anchor points for quick adjustments, and you can rotate or move the setup as needed. There are also shape presets, so you can change the plane profile in seconds. To create objects, such as floor joists, extrude the plane profile to the length you want. The joists are automatically spaced at the CC distance you set, in this case 600 millimeters. Use close frame to generate the full floor frame. Set your lumber dimensions, generate the objects, and save them into a group. It's worth naming groups as you go to keep everything tidy. Once you're familiar with the tools, this step takes only a few seconds. The measurement is saved temporarily, so you can reuse it for the walls and simply adjust a few parameters and placement. If you toggle the CC option off and on again, the green previews return so you can edit them. Creating the wall frames is straightforward because they follow the same CC logic as the floor. Rotate, move, and adjust dimensions to form the walls. Use the sliders for fast placement, then fine-tune with the small arrow nudges in the input fields, or type exact values. Set the wall height and the wall frame is essentially done. If you want the same wall on the opposite side, mirror it, choose the correct axis, and move it into position. In this shed build, we're using rafters, so the two long walls have different heights. I generate the first wall into a group, then reuse it for the other side, move it into place, and adjust the height. Generate and save to a second group. Before adding the end walls, I'll create the rafters. Set a line along the top plate. Turn Snap to Grid off here, otherwise it can be difficult to snap to exact points on the model. A quick note, the CC Tape Measure tool keeps the last used settings, even if you delete the temporary measurements. That's often helpful, but it can be confusing at first. If something looks off, check the tool settings and keep going. If you double-click the small dots on the sliders, they reset to 0. It's much faster than nudging back manually. Instead of rotating nearly 180 degrees and ending up with a confusing angle, you can simply switch the extrude direction and use a rotation that's easier to reason about. Rafters usually need beveled ends. In Autostrek, that's quick with the bevel tool. It may look a little unfamiliar at first, but if you test the options with exaggerated angles, it becomes intuitive. If you adjust the rafter afterwards, the bevel angles are preserved. For roof overhang, use the offset control. Generate the rafters into a group and they're done. Now let's use the plane tool to create the studs for the end walls quickly. The plane tool can be used in several ways, but here we'll set it on a surface to define where the studs should terminate. In this case, I place a plane on the underside of the first rafter, then adjust its width and length. Next, set a new CC line and update the stud dimensions. Here I notice I forgot to reset the extrude offset setting, so it extrudes from both sides of the plane. I'll switch that off, so the end wall studs generate in the correct direction. When I extrude the studs up into the plane, Autostrek automatically adjusts them to the correct length and top bevels. There's no need to model each stud individually. because we're maintaining consistent CC spacing. One stud may overlap another. We'll fix that in a moment. I use close frame to add a bottom plate, then move the wall assembly into position. The plane ensures the stud tops remain accurate. You may notice a top plate appears above the roof as well, because close frame was enabled. We can delete that later. Once the first end wall looks right, mirror it to create the wall at the opposite end. Now I'll remove the overlapping studs and add corner studs to tie the end walls to the long walls. I use the Move tool to pull the overlapping studs out and delete them. I also delete the bottom plates because they're too long. Then I set a new line between the walls. The CC tool keeps the previous settings, so I don't have to start from scratch. The key change here is switching to even spacing. That places all the corner studs, plus an extra center stud that we can remove later. Everything looks correct, so I generate the corner studs and a new bottom plate at the correct length. When generating studs, I save them into the same group as the end walls to keep things organized. Finally, I delete any obsolete objects. For visuals, I can finish by running an AI render of the building. At this point, everything is organized into groups. Autostrek has also created an animated build timeline as we worked. Because I used lumber dimensions that already exist in my product list, the price, BOM, and cut list are ready with no extra work. From here I can generate print-ready documents and start building.